All right, so moving on from our talk about polyhedrons and Euler's formula and different things, now we're going to be moving on into surface area of prisms and cylinders. So we're going to be doing prisms and cylinders first, and then kind of moving on into other shapes, dealing with prism or surface area, lateral area, and everything. So right now we're kind of doing the simple ones. Okay, so the first thing is a prism. So what a prism is that it's a polyhedron that has exactly two congruent and parallel faces. If you think about this, a triangular prism, that thing where if you shine light through it makes a nice rainbow coming through of it, like in the previous slide. Okay, but what a prism is that it's a 3D figure. So if I have a triangle up here, I'm going to put another triangle down here. That's exactly the same, and then we just connect it. That is what a prism is. And so you've got two sides that are exactly the same, and those are called the bases. And those are the congruent parallel faces of the prism. After that, it's all the other sides are called lateral faces. Okay? And these are usually quadrilaterals. Okay? Four-sided figures. And so they make up the sides of it. And so if you look at this, if we have this case right here, we're going to be, okay, here's a rectangular prism, here's a pentagonal prism, here's a hexagonal prism. So the first thing we'd want to do is identify where the bases are. And the bases in this case are right there. They're the sides opposite that are congruent to each other. Now the rectangular prism, you might make an argument, well, it could be somewhere else. Well, yeah, but with a rectangular prism, it doesn't really matter which ones you pick because it still comes up to the same. But for the hexagonal prism and the pentagonal prism, you need to pick the pentagon and the hexagons as your bases. Okay, so those would be considered your bases. As you see, those two are the same, but if you look everywhere else around, these are all rectangles. And that leads us to what's called the lateral area, or the lateral face. And the lateral face is all these rectangles that make up the rest of the prism along the sides. Okay, so the lateral faces are the rectangles that make up the sides of it. Okay, now altitude and height. So the altitude is if you were to drop a line straight from one vertex straight down, and so it's perpendicular to the base. This is called the altitude. It's the line segment. Okay, so the line segment is called the altitude, but the actual number or the length of the altitude is called the height, which we will denote as h. And so the height is kind of the key thing. And even if it's kind of slanted off to the side, the height still is going to be the same no matter where it is. Again, the height we want to know is the altitude of it. So even if the figure, is the Leaning Tower of Pisa where it's like this, we're looking at this length. This is the height. Okay, that's the height, not this length. We don't care about that length as much. We care about the straight up and down height, and that deals with something called the Calavari principle, which we'll talk about later. Okay, so lateral area. The lateral area is the area of all the lateral sides. So if you were to add up all the area of all the lateral sides, which are usually all rectangles, that is your lateral area. Okay, and the lateral area of a right prism, when we've got that shape, is the perimeter of one of the bases times the height. So you remember what perimeter is. Perimeter is the length around the figure, okay, and then you multiply it by how tall it is. Okay, which if you think about it, if we've got, let's say, this rectangle, and if we want to find the length of all these sides, okay, it's going to be length times height plus however many there are. Well, how many L's are there? There's 1, 2, 3, 4. 4L times H will tell you the lateral area. Okay, so the lateral area of this. So if we want to find the lateral area of this hexagonal prism, what we would do is that we would find the perimeter of the hexagon, which, as we see, it's a regular hexagon, so all the sides are 20. So 20, 40, 60, 80, 100, 120. So we would go 120 or how we got that was 6 times 20. And then we would multiply it by 9. And that would get us our answer of 1080 inches squared. Since we're dealing with area, we would say it's inches squared, or whatever our unit is squared, okay, or square inches. Okay. So don't forget that whatever unit squared for your units on these. Okay. But your lateral area, all you do is you take perimeter and you multiply it by the height. Now, the surface area. The surface area of a figure is the lateral area plus the area of each of the bases. And so you can think of surface area as equal to LA plus 2B. That's one way of thinking about it. Or, if you don't want to try to remember what LA is, you can say SA is equal to PH, perimeter times height, plus 2 times the area of the base. This capital B means area of the base. Okay, so that's what the capital B stands for. It means the area of whatever the base is. Okay, so that's what surface area is: lateral area plus the area plus 2 times the area of the base. So here we have here this pentagon. Okay, this pentagonal prism, and what we're going to do here is that we want to find, okay, well, what is LA? LA is going to be equal to, well, 5 times 5, so that'll be 25 times the height, 10. So it looks like our lateral area is about 250. Okay. Now after that, we're going to have to find, we're going to go 2 times the area of the base. Well, what is the area of the base? Well, if you remember from our previous chapter, the area of a polygon is 1/2 AP. Okay, so the perimeter is 25, so what we have to do is we have to find our A, in this case, our apothem. And so you're going to use some trig, possibly, for this. To be able to find out what this altitude is, or this apothem would be. And once we know the apothem, we can plug that in and find it, and we end up getting that it's approximately, after we take 250 and then we add it to 2 times the base, so 2b, again, once we find our apothem, we add them together and we get about 336 centimeters squared. Okay. And so that would be our surface area of this figure. Okay, so it's the lateral area plus 2 times the area of the base. Okay, so those were for prisms. So for any type of prism, you're going to want to do that. So make sure you remember your area of a polygon. Okay, 1/2 AP. Okay, review on SOHCAHTOA or trig functions. Help you find those. All right, lateral area for what's called a cylinder, or a soup can. A barrel type of thing. So the lateral area for a cylinder, okay, which has a circle on top and bottom, the lateral area of it, which is this kind of bluish greenish shape, is the perimeter of the circle, which is called the circumference. The circumference of the circle times the height of it. So the circumference of a circle is 2 pi r, or pi d, and then you would multiply it by its height. Okay. So if we're looking here and we want to go, okay, what is the lateral area of this? We want to keep it in terms of pi. We would go, okay, it's 2 pi times r times the height. And so it looks like it's going to be 8 pi times 8, which would be about 64 pi meters squared. Okay, and that would be the lateral area. Okay, so now after lateral area, we have surface area, which is the same as the surface area for a prism, where we take the lateral area and then add 2 times add the area of both bases. Well, the area of each base of a cylinder is the area of a circle, which is pi r squared. That's the area of a circle, and so then we would double that. Okay. So if we're looking here, 15, 16, so we have 2 times 15 times pi, and then times that by 16. There's our lateral, there's our LA, and then we're going to have 2 times 15 squared pi. And once we get multiply all that together and then add it together, we get about 930 pi inches squared as our answer. Again, inches squared is important. That is our unit of this figure. Okay. And so that is for your surface area. This tells you your surface area of your object. Okay. All right, your IRAT. So you got two problems. One is with a hexagonal prism. Find the lateral area of the hexagonal prism where each side of the, it should be a pentagonal. Pentagonal. It's a pentagonal prism, so five-sided pentagonal prism. Each side is 5 inches and the height is 10 inches. Find the lateral area of it. And then for the second part, find the surface area of a cylinder with a diameter of 22 millimeters and a height of 5 millimeters. So it's a very short and wide cylinder we got here. Okay, so find the surface area of the cylinder and find the lateral area of the pentagonal prism.